Hi, everybody. Let's talk a little bit about some proportions that were giving us trouble, and maybe some more complicated or advanced ways to solve them. We saw this in one of our homework assignments. It said that 6 halves were equal to, or in this case, proportionate to, 21 over n. I say proportionate to because these are ratios. We don't have any labels, so it's not easy to see, but let's just call them ratios. And we thought, several kids said, there is no factor that will change 6 into 21, or at least no whole number factor that I know of. So how can I solve this? Well, okay, let's take a little side tour here and talk a little bit about logic and algebra. In the inside of every algebra book, you're going to see this, something that says that if A equals B, and if A equals C, then B and C must also be equal. Now that's a little vague and hard to understand, so let me try and present it in a different way. I could say that my name is Mr. Meyer, or let me try and make it match the yellow here. I'm going to say that me, who am I? My identity, Mr. Meyer. I could also say that my identity, me, I have another identity, and that's Jim. All right, and those statements are both true. And from this, we can probably figure out that, wow, who this guy is, that's Jim. He's also known as Mr. Meyer. Mr. M. Right, and that sort of makes sense, right? We see that if A equals this and A also equals this, then those two things must be the same. Okay? And we can apply that same reasoning to this. One solution is to simply make another identity for 6 halves. So you can just write, we'll simplify it, right? That's 3 over 1. And if 6 halves equals 21n and 6 halves equals 3 over 1, well, then they are the same thing, right? We could say 3 over 1 equals 21n also. They're both the same. And then it's easy to see the factor, right? 3 times 7 equals 21. And then, of course, use the same factor here, and we have solved n must equal 7, right? 1 times 7 is 7. Now, that's a simple way to look at it, but let's look at it a different way, right? Let's take the same problem, and this is where we'd like to do our heavy lifting here, our thinking. 6 over 2 equals 21 over n. And we talked about cross-multiplying, right? We're not going to talk about why it works right now, but we know that if I multiply these two numbers together, I will get 42. And I know since these ratios are proportionate, that these cross products should be the same. So I know that n times 6 should be the same as 42. Those cross products should be equivalent. Right, so now we have this little problem here. N times 6 equals 42. And you should know that when you have a missing multiplier, right, there is a mysterious factor here we want to multiply, but we don't know what it is, that can be solved through division. So you can simply set up a division problem, 42, and we're asking what number times 6 equals 42. Those are our factors. So what I'm going to do is, well, I'll leave you to figure that out, but that's how you would set up the problem, right? And again, it should come out to be the same. N should come out to be 7, right? And it does. So again, we find out that n equals 7. Okay, so if a ratio can't be simplified, like we talked about in the first screen, right? If it can't be simplified like so, then you can use cross multiplication, and you'll be missing one factor, or there'll be a missing multiplier, and you can solve that through division. Okay, fantastic. This is a great tool to have. Please learn it, live it, and I promise you'll use it. See you later.